working towards strengthening growth of Indian textile sector and address the pressing issues facing the industry. Technical textiles refer to textile materials and products that are manufactured for non-aesthetic purposes. These textiles are specifically designed to have unique properties such as durability, strength, resistance to chemicals, flame retardancy, among others, to meet the specific requirements of various end-use applications. Technical textile products derive their demand from development and industrialization of the countries shaping up. India has a small presence in the global technical textile market, but has potential to become a key player in the industry. The Indian textile market is expected to grow rapidly in the coming years due to a variety of factors, including favorable government initiatives, increasing demand for technical textiles in various end-use applications, and the country's robust manufacturing capabilities. India's strength have already been recognized in traditional textiles and natural fibers. It is the second largest producer of polyester in the world and is now emerging as a key player in technical textile industry, contributing to a market size of $19 billion. Technical textile is a fast-growing sub-segment that finds its usage in an array of sectors. The end-use application of technical textiles is widespread and seen in industries such as defense, agriculture, construction, sports apparel, healthcare, etc. India's leap toward modernization and its manufacturing capabilities are some of the key contributors to the growth of this segment. Technical textiles, a sunrise sector, has become even more relevant during the COVID-19 crisis when the global manufacturing came to a grinding halt. India was entirely import dependent for PPE kits. As COVID havoc was all over the world, the exports of PPE kits were banned by other manufacturing countries, making imports to India nearly impossible. On manufacturing no PPE kits in March, Indian manufacturers took up the challenge and rose to manufacturing 2.5 lakhs kits a day. In around 60 days, Indian producers set up example by becoming the second largest manufacturer after China. Today, India stands to produce around 4.5 lakhs PPE kits and more than 1.5 crore masks a day. Technical textile accounts for approximately 13% of India's total textiles and apparel market and contributes to India's GDP at 0.7%. There is a huge potential to fulfill a large demand gap as the consumption of technical textiles in India is still only at around 5%, as against 30 to 70% in some of the advanced countries. Hence, garnering direct attention from Honorable Prime Minister Shri Narendra Modi ji and his Cabinet Committee on Economic Affairs, a national technical textile mission has been set up that aims at an average growth rate of 15 to 20% to increase the domestic market size of technical textiles through market development, market promotion, international technical collaborations, investment promotions, and Make in India initiative. The Indian technical textile industry is expected to grow at 20% CAGR, with the demand for technical textiles expected to rise in several key sectors, including agriculture, healthcare, construction, and infrastructure. Additionally, the government has launched several initiatives, including the Technology Mission on Technical Textiles and National Technical Textile Mission to promote the growth of technical textiles industry and attract investments in the sector. Technical textiles are made mostly from man-made fibers, and amongst man-made fibers, the polyester is the most important, having a share of 80% in man-made fibers segment. Now, developments and innovations make it extremely suitable for different type of technical textiles. Indian manufacturers are neither short on skill nor on innovation, but are unable to scale up and speed up volume due to perennial shortage of key input raw materials, unfavorable tech structure, and latest equipment and machinery to make fabric and further processing. Though India is second largest producer of polyester, it is still a long way behind China, which has a capacity of 50 million metric tons annually, and India around 6.5 million metric tons only. For success, this mission we suggest some steps which will accelerate growth and make India competitive in global market. Ensure availability of key raw materials, purified telepathic acid, PTA, and monoethylene glycol MEG at internationally competitive prices. Duty-free imports of latest machinery for developing and producing technical textiles. Rationalization of GST on PTA and MEG along with polyester staple fiber from a high of 18% to 12 or 5%. Due to inadequate raw material availability and uncompetitive prices, Indian manufacturers have lost some of its global market shares to other less developed countries like Vietnam, Bangladesh, Cambodia. Effective steps are urgently needed, otherwise gaining a position leadership would be just wistful thinking. This conference provides an opportunity to come together and share knowledge and ideas on technical textiles, which have become an indispensable aspect of modern day life. With the conference goal on discussing the latest advancements in technical textiles, their multifarious applications and their impact on society and the environment, participants can expect to gain valuable insights and perspectives from prominent visionary leaders in the field. With a focus on advancing research and development, industry, academia, collaborations, and government initiatives, this forum provides participants with an opportunity to explore the full potential of technical textiles and their impact on society and the environment. Thank you.
Thank you so much, Mr. Bagaria, for the well-constructed welcome address. And before moving forward, I would request everybody that we'll be giving the profiles of our speakers post the event. My colleague Yudu will be sharing with all the delegates who are present here. So it will be given to you post the event. We'll be not discussing during the event itself to save on time. Moving forward, we have theme address by Professor Abhijit Majumdar, Department of Textile and Fiber Engineering, IIT Delhi. Over to you, sir.
Good morning, everyone. Mr. Madhusudan Bagaria, Chair, PhD CCI. Mr. Rajiv Saxena, Joint Secretary and Mission Director, NTTM, Ministry of Textiles, Government of India. Dr. Arindam Basu, Director General, NITRA, Ghaziabad. Dr. Nandan Kumar and Mr. R.K. Vij, the industry leaders present in this August gathering. Researchers, students, ladies and gentlemen. It is my privilege to deliver this theme address, and I have chosen a topic which is related to the knowledge and education because I represent IIT Delhi and I am teaching there for last 16 years. So the topic of my deliberation would be how to build human resources for the growth of Indian technical textile industry. So I'll talk about the origin of textile education, followed by current status of textile education in India, problems of textile education, and does technical textile need a new program? And finally, I'll conclude. The reason why I've chosen this particular topic is that it has been discussed in several forums that technical textile is a knowledge-driven industry. So it doesn't mean that our traditional textile doesn't require the knowledge, but probably technical textiles requires more science-driven knowledge and research-based knowledge. So if you look at this, production function, we need capital investment for the machines. We need labor, we need raw materials, and then we need technology, which is having two facets. One is knowledge, and then engineering and managerial skills. So I'm actually covering this part, the knowledge and engineering and managerial skill part. So what is the Indian scenario in terms of technological education? So we have seen many news reports that most of our graduate engineers are not employable. This was a comment by the CEO of Tech Mahindra in 2018 that 94% of the IT graduates cannot be employed because they do not have the basic knowledge of programming or the emerging technologies like artificial intelligence and machine learning. Now, if you move from the IT education to the textile education, this education is very, very old because textile education came into existence during the first industrial revolution. Today, we are talking about Industry 4 and Industry 5 as well, but this textile technology education came into existence between 1760 and 1804. So, and during that period, we have seen many inventions like the spinning jenny, and you can see the child labor being used to operate them. This is the flying shuttle loom. So these are the inventions which actually transformed the textile education, and from art and craft, it became a subject of technology. If you visit the Science and Industry Museum in Manchester, you will see the kind of innovation, the kind of mechanization they have done to develop the spinning machines and the weaving machines, and they have preserved them in a very beautiful manner. So if you look at the textile education and its inception in India, of course, it started in UK alongside the first industrial revolution. And then formal textile education in India started in the year of 1887 when the Ripon Textile School was constituted in VJTI, Mumbai. And then, the textile colleges in the eastern part of India, Berhampur and Srirampur, they came up along with the Government Central Textile Institute in Kanpur. So this was the scenario before the independence. Now, all of us know what has happened in last 3 decades. The textile industry, basically the commodity production has shifted to Asian countries in 1990s, post the GATT agreement, and there are many renowned departments in USA and UK which were actually disseminating the textile engineering education, like Georgia Tech University, Clemson University, Manchester University in UK, Leeds University in UK. They converted their focus and they either became a department of design or they merged with the material science because the manufacturing was not happening in those Western world. So the onus was on us to take the textile education forward, but to be honest, we didn't do a good job in that respect. So now I'll talk about our textile UG program and what are the flaws in it, because I'm in this profession, or rather which I call it as my passion for last 25 years. And we have a major flaw in our textile education because at the UG level, we over-specialize. And now I'll try to highlight what are the problems. We have around 40 degree colleges in India. Total engineering graduates, textile engineering graduates, which are coming out, they're around 3,000 in number. And we offer UG programs in textile engineering, textile technology, textile chemical processing, man-made fiber technology, apparel engineering. And now with NTTM, we are thinking about starting another new undergraduate program in technical textiles. So in IIT, we have only one undergraduate program, that is textile technology. But if you look at these 40 colleges, you will find different textile programs in different package, in different names. Now, is it correct? Is it principally correct? Is it fundamentally correct? Let us look at other engineering branches, mechanical engineering for that matter. They have specializations like thermal engineering, design engineering, production engineering, and industrial engineering. These are the specialization at the postgraduate level, but they have only one undergraduate program, that is mechanical engineering, And at some places, you may find industrial and production engineering. If you move into civil engineering, at the postgraduate level, you will have structural engineering, water resource engineering, geotech engineering, rock mechanics, transportation, and environmental engineering. But when you go to the undergraduate, it has to be all encompassing. We need to find out the common thread among all the specialization, and we need to come out with a nice UG program which will talk about principles and fundamentals. So in civil engineering, you have only one undergraduate program, but they have many master's programs. In textile, it is just the other way around. We have 6 undergraduate programs, whereas if you talk about master's program, basically there are 2, textile engineering and maybe textile chemistry. Now the other point, do we need a new UG program for the technical textile? For PG, it is fine. Technical textile is specialized, and you can have a PG program, but do we need a UG program on technical textiles? So my opinion here is, what is technical textiles? Here you can see bulletproof material, fire protective material, UV protective material. So these are the productification or product form of high performance and functional fibers. These are just the productification done by specialized machine using high performance or functional fibers. So if you stick to the principle, high performance or functional fibers should be taught in fiber science, whether it is Kevlar or hollow fiber or trilobal fiber, antibacterial fiber, any functional and high performance fiber should be part of our fiber science program. What about the structures? We have a undergraduate courses on textile structure. So it may be oven, non-oven, then you can have these braids, you can have these nets, you can have this spacer fabric, 3D fabrics. This should be part of our structural courses. Manufacturing techniques, you can have weaving, knitting, non-woven, and braidings. So if you look at the principles, these things should be covered in our fundamental subjects. What about the employment? I was part of the IIT Delhi team which conducted the baseline survey on technical textile industry in India that was supported by Ministry of Textiles. So we found, when we did the survey in all the textile colleges in India, we found that the current placement is only 5% in the technical textile industry. Remaining 95% graduates are being employed in the yarn, fabric, fiber, or apparel manufacturing industry. So we need to look into that, because if you create another undergraduate program, we are creating another over specialization at the UG level, and whether they will be employable or not. That is the question. So how to address the problem? This is my way of thinking, that how to overcome this over specialization and how to make a UG curriculum which should be principle based. Let us look at the output systems or manufacturing system. We have inputs, then we have manufacturing, and then we have the outputs. In academic institute, our inputs are students, and our outputs are the inputs for your company. Those are the engineers. So as process, we have curriculums, we have teachers and labs. I think our major problem lies here. Our students are not that bad, though it is the fact we do not get good students nowadays for textile program, but except computer science, who gets motivated students? I was in a very nice private university in NCR for one examination, and I found they have 600 students in computer science, and in mechanical they have only 13. So it's not about textile. All other core engineerings are suffering, whether it is mechanical, civil, chemical, metallurgy. They're not getting motivated students. So we cannot complain, we cannot grieve that we are not getting good students. It is our responsibility as a teacher to build a solid curriculum and good laboratories, and we need to produce good engineers. Now, if you look at this, you will find that in all other engineering branches, this is the data from AICTE. If you look at what is the percentage of seats, engineering seats, which are available in government colleges and government universities, this is a very staggering figure. Civil, computer, electrical, electronics, and mechanical, only 5% seats are available in government colleges, but in textile it is 42. What does it indicate? The textile technology education or textile engineering education doesn't have that business perspective. So government has to take the onus And government has already taken the responsibility to run on these departments. And as these 40% seats are in government colleges, education is almost free. So we are supposed to get good students coming from relatively not so affluent families, but academically they are good. Now, what are the curriculum focus for textile engineering? And it is very important for technical textile as well. Materials part should be covered because in any engineering program, there are three segments: material, structure, and then manufacturing process. So material part should be covered in fiber and polymer science and in nanomaterials. Structure and design should be covered in fiber structure, yarn and fabric, and clothing design and pattern making. In manufacturing processes, there are two segments: dry processes like yarn, fabric, and garment manufacturing. There may be wet processes like coating, lamination, dyeing, and printing. So this should be the curriculum focus. Now, the existing curriculum is actually information based. It didn't really provide the knowledge to the students. We just bombard them with information and data, which doesn't make a good engineer. So what we need to do, taking the blue ocean strategy from business, I propose that we need to create new value. We need to create those contents in our curriculum which will create new values. We need to eliminate those components which do not add any value. We need to raise certain things and we need to reduce certain things which are less value adding. So what we need to do, we need to have a principle-based curriculum. We need to build core competence in certain fundamental engineering, which is very important for technical textiles. If you are developing cold weather clothing for CHN, you need to know how the heat and mass will flow through the fibers and fabrics. So you need to have the knowledge of fluid mechanics and thermal engineering, which is currently missing in our curriculum. Operation research, because in textile, a lot of optimization is needed. So you need to know how to solve linear programming, transportation, and assignment problem. You need to have more knowledge about fiber reinforced composite, and AI, ML, and data science are very, very important. What we need to eliminate, too much focus on manufacturing. How the spinning is done, how the weaving is done, how the chemical processing is done, all data and recipe, this should be eliminated. We should raise the material focus, we should raise the polymer and fiber science part. Advanced material characterization is very important for technical textiles. All these characterization techniques must become a part of our curriculum. Functional finishes, technical textiles, warp and full garment knitting, and operations and financial management, because every engineer should have the fundamental understanding about the operations management and bit of financial management. Because at the end of the day, I would like to see my bottom line. You can talk about any technology, but if it doesn't give you positive NPV, as an entrepreneur, you will not be interested. And what we need to reduce, parameter-centric learning like twist multiplier, machine setting, speeds, productivity, recipe of chemical processing. These things can be found in handbooks. No need to teach them in the academic institute. Shuttle looms. I teach fabric manufacturing in IIT, and still I am teaching shuttle loom. Is it really required? So role of industry, this is very important. Create an atmosphere where technical manpower gets the due credit. They get due credit for their knowledge, due respect. Recruit them for knowledge, train them for skills, and retain for mutual growth. Don't expect that engineers will become, their finished product. It is not possible. Whatever infrastructure you give, from college you will get raw engineers only. They will never be the finished product. We have our own limitations in academic institute, but you should recruit for their attitude and knowledge and then train them for their skills. Give them a decent compensation. When our master students come from industry during convocation and they say, sir, I have got a good job, but my package is only 5.5 lakhs per annum. Then the market pool is not there. I'm sorry to mention this, but this is the current state of affairs. In IIT Delhi, we produce only 30 postgraduate engineers, and they are not getting due compensation. Stop the debate about employability versus employment, because we say that employment is not there. Industry says engineers are not employable. Okay, so this debate between academia and industry, whether it is a question of employment or employability, I think we should shake hands and we should work together. And these are my conclusion. Textile programs are over specialized at the UG level, and this is a fundamental flaw that we have. Unification is needed by focusing on principles of material structures and processes. Process focused must give way to principles. Parameter centric learning must be eliminated. We must strengthen the core competence, which cannot be mimicked by our competitor. Otherwise, what will happen? Even the technician who works in the industry for 2 months, they become equivalent with a BTech engineer who has spent 4 years of time. We need to focus the core competence, and we must leave the skill part to the industry. So this is my request to all my industry friends. You need to train them for the skills. Thank you very much.
Thank you so much, Professor Abhijit Majumdar, for such a well-constructed and well-organized presentation. We got the information from the past, present, and I think you have also many suggestions for future. Thank you so much. Now I'll call Mr. Nandan Kumar for the address, and he's the director at High Performance Textile Private Limited. Over to you, Mr. Nandan.
Thank you so much. Good morning to everyone. First of all, I'd like to thank Secretary Sir, Mayank Sir, and PhD Chamber for organizing this event and giving me a chance to share my view. As Sir has mentioned, we are from a small manufacturing company, I'll say. We have two setups, one in Panipat and one Sonipat. So I'll try to share our views or what challenges we are facing when we are trying to develop or trying to become a global leader in field of technical yarns. So again, I will repeat the thought. It's not about doing job work for big companies. It's about being the global leader in this segment. And last 12 years, before this, I have done my PhD from University of Leeds. I did my master's and PhD. And so although we are into manufacturing, but by core, I'm still a researcher. And we try to solve these problems. The only difference is we try to solve the problem and then we try to scale it up. It's a difference when you make a yarn 1 kg and 2 kg, or when you can do 10 tons of export in a month. There's a slight difference, and that's what we need to focus in today's time. So very quickly, I will give a brief introduction about our company. Then I will jump straight on the problems, what we are facing. So like I said, we are processing staple fibers as well as filament. And we try not to promote one fiber, which was the case 20 years before. 20 years before, if you go to any industry, you will see only yellow gloves with the brand name of Kevlar, fantastic fiber. But now those days are gone. It's about achieving the properties. So rather than having 100% of one fiber, if you can achieve same property by blending 2 or 3 or 4 fibers, even getting the better properties, that's what the recent trend is. So we play with a lot of fibers, a lot of filaments, and we try to develop a yarn which is as per the requirement. So we have Aracore, which is based on Aramid, Flex is based on HPP. Protective textiles, as we all know, it's not a new area. It's there from very long time. The difference is trying to make it comfortable. A very good example, if I give this glove to a worker in steel industry, he will still try to wear it 5-6 hours in a day. But if you give him a very heavy gloves, which performs really well, and you tell him to work for 12 hours wearing that, impossible. So what's happening? We are providing protective gears to our manpower, but they are not using it because it's not comfortable. So the new trend or the new fight is happening on making the products much more lighter, much more comfortable, yet achieving the properties. So we are very focused on all this protective segment, although now we are trying to develop a new products for automotive industry also. When we talk about sound and thermal insulation, all these are related. Again, coming back to key areas of innovation or where our country we should focus on. We all know staple fiber blending is not a new technology. It's very old technology. We are blending polyester, nylon, cotton in a big way. But when we talk about technical fibers, a lot of work needs to be done both from industry side, academic side, as well as testing lab facilities. Very good example. So this is one fabric which is very commonly available in India. This is 100%. They call it 100% pyramid woven fabric, 480 GSM. It's huge in India. It's a huge volume. But right now, what's happening? Because not many labs in India can do composition testing. You know, if I give this sample to a lab in Panipat or any tier 2 or tier 3 cities and ask them to confirm composition testing of para-aramid, nylon, and monoacrylic, or forget it, they cannot do it. And we have to rely on Atira, Nitra. They are doing good job, but our problem is small companies are in Panipat or Sonipat or tier 2 cities. They don't have time to go to Delhi, Mumbai, Chennai, and sometimes they don't even know what to ask, how to ask. So it's time that we should try to train all these NABL labs which are trying to get into technical textiles. We give them a basic knowledge of how to do composition testing so that substandard or pirated products are not being imported into India. So company like ours, we are competing with yellow cotton blended, aramid blended fabrics coming into India. We have 30% of yellow cotton blended with para-aramid, and that is being supplied in industry. And guys like us or companies like us, we are struggling because we cannot match the price using 100% of para-aramid. And these are the challenges which we need to address. And for that, definitely it's a joint work from industry, from academics, from testing lab. We all need to work together because this is something going in a completely different direction. And it's time we should focus on this. Otherwise, India will be the place where all substandard products will be dumped. And I'm seeing that almost every day. So staple fiber blending is something huge potential for India, especially for small companies, whether it's a weaving, spinning, or dyeing, finishing. Here, again, when you blend fiber to fiber, you can reinforce with steel wire, glass, basalt to achieve certain properties. Once again, this is not a new concept, but the moment you put aramid or high performance materials, it becomes a new concept because single kg of yarn can cost up to $40 or $45 a kg. So we are exporting a yarn which costs $150 a kg. The reason is costly because it's having tungsten. Tungsten itself is $120 or $130 a kg. So it's time we should focus on, or we should, like Abhijit sir has rightly said, we should try to bring these things in our courses, or at least we should try to give them a flavor that these are the trend, these are the new patents filed in this area. Just we have to go through last 5 years patent. That's it. We have to prepare a summary of those patents, and we have to educate our undergrad students in final year that these are the new trends, these are the terms you need to know. Rest industry can guide them. This is a very recent trend, but I can see huge potential of these type of yarns coming into India, where we are not putting any metal inside. In recent times, it's about recycling of all textiles. The moment you put tungsten, steel, or glass in the core, it's very difficult to recycle these products. So now what's happening? Filaments are being used in the core with staple fibers on the sheath. So we have recycled para-aramid having virgin para-aramid filament in core, and that yarn is taking care of a lot of new developments. So we are also working on a graphene-based HPP, where we are trying to replace some of the metallic products. Now, filament to filament twisting, again, it's not a new concept, but it's very interesting for our country because you can twist high performance materials with commodity fibers, which are easily available in India. The best example is aramid being twisted with high tenacity nylon, or even we are twisting high tenacity polypropylene with steel wire to achieve certain properties without using any costly materials for our own domestic market. If we can't get hold of these yarns, we can also do blending in the form of fabric. This is a very good example. We are trying to develop a denim. One side is cotton and other side is ultra high molecular weight polyethylene. Now, honestly, although it looks very difficult, but a small weaver can do these things. The challenge is testing, Understanding whether these ultra high molecular weight polyethylenes are available, because if you are doing some development and later on you come to know that okay, these are not available in this country, whole trial is waste. So that's where we need help from testing labs, which can guide us that these are the parameters, these are the suppliers, and these are the reliable vendors where you can go and easily buy. I asked for this concept of Library of Technical Textiles 1 year before, and we are trying to work on that concept with IIT Delhi, where we are trying to share the data of all these raw material suppliers so that small companies can trust and buy these raw materials for their own testing and validation. Same garmenting also, a lot of blending can be done. The best example is the whole shirt is manufactured using FR treated cotton, which is very low cost, but the sleeve areas are manufactured using para-armid fabric. Denims reinforced with knitted fabric. Once again, students, they need to learn about this concept. Testing labs in India, they should be able to test these materials, and small companies, I'm sure they can follow these sort of trends. So coming back to the main summary, that in technical textiles, product development is very important, especially if you are aiming to become a global leader or one of the global leaders, having your own set of developments. It's a very good example I have tried to share here. Like you have two types of gloves. One is having aramid in it because it's needed high performance. But other side, a company in central India, they were looking for cut resistant gloves, but not very high level and not for heat resistance. So we designed a very basic gloves having polyester and steel wire and nitrile coated. Now that gloves is doing fantastic, and it's a low cost as well. And we are not dependent on any imported high performance material. So what's happening? Using our own technology, using our own resources, still making a technical product, which can be very interesting for our market. So for all these, testing and validation is very important. And I'll request we should not blame everything on testing labs. Any small companies, if you want to become leader in this area, you should invest in your own R&D. Small portion of your turnover should be invested in testing validation. That's how you can learn, and that's how you can jointly work with testing labs and develop new range of testing or protocols. So we have set up all these machines in our own factory, and we are working with a lot of students from different institutes. They are doing project with us, and we are trying to create awareness on thermal hazards and mechanical hazards. Now, this is one example. I just wanted to share this video. I don't know if this video. I'm sorry, that video is not working here. I was just trying to explain that for technical textile companies in India, we have to fight two types of war. One side, we have to develop this product at a cost-effective way. Other side, sometimes we have to educate our clients. In this example, a very reputed automotive manufacturing company, they are using 100% aramid gloves, and the guy has to scratch the surface of surface of car throughout the shift. In 3 days' time, abrasion of that palm area will be very poor. And what will happen? He will lose cut performance very quickly. So what we did, we educated this client that, rather than using without coating gloves, you have to use coated gloves so that, the abrasion properties are improved. So these are the challenges, or, that's how we should be looking forward. We are also working on real life flash fire testing kit, where we are trying to develop our own small testing rig, where we can do real life situation testing, because most of the testing what we have talked is a bench scale testing, and these are the real life testing. Different types of sensors we are working on. Recycling, once again, it's a challenging area, and not a single company can do this type of project. It needs joint work of industry, academic. We are talking about recycling of high performance materials. I know a company in Panipat, they are recycling 300 tons of aramid every month. Sorry, not every month, every year. But he has no idea that para-aramid should not be kept in outside sun. He doesn't know that it's not UV resistant. He is washing it and he's keeping in day sunlight to dry it. So he has done fantastic job by securing contract of recycling aramid. He's importing from US and recycling and selling it to Japan. It's a fantastic work, but he needs help. He has no idea what he's into, and tomorrow if anything goes wrong, the companies will blame that company. So we have companies and they are desperately looking for support. And I would like to thank NTTM It's a fantastic initiative. We have submitted over 10 applications in partnership with all the institutes in India. And I really look forward for more and more initiative where academics and industry, they can work together, and students, they can do their PhDs or masters based on these projects. And yes, I'm really happy about this initiative. Thank you so much. So with this, I would like to conclude my sessions.
Thank you so much, Mr. Nandan Kumar. It was a fantastic presentation, and thank you for coming up with these set of examples also, because it always helps. Thank you so much once again. Now, please allow me to invite Dr. Anindam Basu, Director General, Northern Indian Textile Research Association, to give his address. Thank you.
Good morning. Good morning. At first, I wish to thank PhD for inviting me to present my views. Mr. Madhusudan Magaria, Professor Abhijit Majumdar, Mr. Nandan Kumar, Sri Saxena ji, Mr. R.K. Vij, all my colleagues, because I have been working with industry for last 40 years. So all my colleagues. So I will start presentation with some numbers, and then I will come to more detail. Next, please. Okay, I can do it from here. This is the figures, because why I'm trying to tell that this is a positive side of technical textiles. Because if we think that technical textiles will go like a mass products and we have a very big scale, it's not possible, because these are specialized products. But why we should go for it? Because the reason is we cannot compete with Bangladesh, Vietnam and low-cost countries. So we have to go for high-value products where products they will not be immediately copied to us. Because earlier days we used to tell, oh, India is cheap labor, so India can do this, all these $1 banyans and all these things. Because now the time has come that we cannot depend on them, because those area has been taken over by them. Even if you see in Bangladesh also, the productivity of per worker in garment industry is much higher than Indian industries. Earlier, Sri Lanka used to be good. Now Bangladesh also has crossed us, even productivity. So the cost, we cannot compete unless we work on that area. So the best area is this, where you need a knowledge-based industry. Market may not be very big, but high profit margin will be there. So you can see, because Nitra is actually the center of excellence for protective textiles and automobile. You can see in protective textiles, 50% growth is there, export, in 10 months time. Recent, I'm telling you, recent. And if you say mobile tech also 20%. Why you see 1%? Because the majority scale is in pack tech. You can see in the total scale, pack tech means, even jute bags also pack tech, which may not be highly technical fabrics we tell, but that comes into pack tech. So that is the scale, it has become 1%. Otherwise, you see the few medical textiles also, we are having very good export potential and seeing this. Yeah. Now, what are the products, top 10 products you are exporting? If you can know, you can see here that. You see flexible intermediate bulk containers, because in packaging, other cordage, polythene, polypropylene, you can see here, this is the value in crores. So these are the major first 10 products, top 10 products we are exporting. Now I go to the import. Also we are importing different technology, textile, products we have done. This has been 7% growth is there. Now here also we see what are the things we are doing. You see this. Safety airbags with inflator systems. It's a huge market. Where these are, why I'm showing this area here, we have got a great opportunity to bring in. because these are the things being imported totally. Even I have been in touch with many automobile industries where they are very restrictive. They believe on only 2-3 companies, and beyond that they don't want to give the standards also, nothing that. So here we have to penetrate, because for one of the projects we have been trying with 4 companies quite long time. It's very difficult to penetrate because even they don't want to change anything new. So that is the major problem we have. So these are the areas where we can do a lot. Now global market is supposed to be by 2030 276.8 billion. This is the presently it is 189.2, and CAGR is 4.9%, 5% in the world. In India, it's much higher because India, as he told, our penetration level is much low, where penetration will be much higher. So our penetration growth can be much higher. See, this is one given, I think you see Invest India, they have published this one, that India is going through infrastructure development so much, and each of them needs some technical textiles. So there is a huge scope of bringing this product. So these are the products. You can see these roads, ports, the Sagarmala, Bharatmala, Udan, all these projects need technical textiles, many cases geotextiles, many of the cases geotextiles mostly. So you can see that there is a huge market in India itself. Okay. This is, I think, Ministry of Textiles recent, they have come with this figure. The total market size 22.5 billion in technical textiles business, and total trade 2.85. Penetration level, as I told, 10 to 12% in India, but in developed countries it is 30 to 70%. That means there is a scope. Now I come to that. What is technical textiles? You add some functional value, it becomes technical textiles. See, presently, you know that one QCO has come, quality control orders, that every material used in public places should be flame retardant. That means the curtains, carpets, even the furnitures should be flame retardant. So automatically that becomes technical textiles, and that has become opened up a huge market. In the same QCO, you can see that protective workwear is must. So these, as I told, these quality control orders are there to make proper use or improve our quality of life. But when you are improving our quality of life, automatically your market also grows. So this technical textiles, as somebody told, that technical textiles is related to development. So as more developed will be there, more technical textiles. So you can see here that QCOs, these 2 QCOs will help a huge amount of pushing of protective textiles. Okay. Then earlier what happened, the problem was there that whenever, because many of the protective textiles buyers are government bodies. In those cases, they were telling there is no standards, because to make any tenders or anything, they need standards. So you may know last, because I am a part of this standard building with BIS for quite some time. And now I think 500 standards have come on technical textiles itself. So some more, I think 100 or 120 continuously working on. So there are standards are coming. But as you know, these technical textiles, the every use variation is there. So standards will be higher, much more number, because every product is something different. For example, I tell you, flame retardant fabrics. Now presently, when we are making a standard for the children's garment, like foreign countries, we have introduced now, it will come soon. Introduced now, this children's means the smallest children, there are 2 groups. One is 3 up to 3 years, another is 3 to 14 years. In those cases, especially up to 3 years, there should be flame retardancy. Because these children, when it goes near to fire, it should not catch fire. It is in all developed countries, it is there. It was not in our standards, now we introduced now. Because that last meeting itself, this we have got TXT 20 committee, which I'm chairing. We have introduced intentionally that we have to protect our children also. At the moment you put that become technical textiles, and its penetration level will go high because you have to buy with these standards. So it is a very good step from Ministry of Textiles also. They have given these products to be covered under BIS, because time to time they have called the meeting to BIS and they told these are the products, make the latest standards and make the good standards. Maybe after some time it become QC also, but before that standards has to be generated. So these standards, what we are making, we are trying to introduce all these features in it, so that it protects our people, protects our children, and also it becomes technical textiles. Similarly, now, as we started growing these productive textiles, most 99% of the technical textiles are produced from man-made fibers. Now, whole world has woken up and told it's not good to have non-biodegradable fibers. For example, let me give simple example. More and more penetration is there for hygiene products in every part of India. Now, where this waste goes? These are not biodegradable. So that becomes a burden for us. So afterwards, it will become a huge burden for us how to do it. So now many of the companies have started going for their products differently. For example, we are working with a company and we have given the product also washable ladies hygiene product, so that after washing also it will be antimicrobial and all these properties should be there, but disposable things should be reduced. So this is one area people are working, and I think whole world will be looking for it. We were working with a company, mainly this is sponsored by the government of India only, where we are trying to put more and more natural fibers in automobile. Because in automobile, there are head cover everywhere the products are used. You just see that it is very all are synthetic products. So now the policy has come that after every 15 years car has to demolish. Then when you put that again, that become non-biodegradable. So this problem is there. So gradually we have to introduce biodegradable product also. So we have started working on that, especially we are trying with jute and other 50%, which is good for heat, anti, I would say, good non-conductor of heat and sound. So that is required for all the cars, the covers. So that we have started. So this is the new trend going on. I think I will not use this because time is over. I will not cover this. Thank you. These are the areas just I've started thinking. That's it.
Thank you so much, Dr. Anandan Basu, with all the facts and figures. Thank you so much once again. And now it's the time to call our guest of honor for the day, Mr. Rajiv Saxena, Joint Secretary, Ministry of Textile, Government of India, and Mission Coordinator, National Technical Textile Mission. In April 2022, Mr. Rajiv Saxena joined as the Mission Coordinator for the National Technical Textile Mission. Earlier, he has given his services to the National Highway Authority of India and various other important government departments and ministries. We are eager to hear, sir. Over to you. Thank you.
Very good afternoon to everyone. All the persons sitting on the dais, Mr. Madhusudan ji, Mr. Basu, and all the dignitaries on the dais, ladies and gentlemen. First of all, I would like to thank PhD Chamber of Commerce to have organized this conference on technical textiles, which is known to be as sunrise sector. It encompasses different aspects of our human lives, not only from trade perspective, but the quality of life also. Even agro textiles are technical textiles, means it increases the productivity of the crops. So this is one example. And this technical textiles has functions across the ministries, across the departments. So the topic of this is market growth, opportunity, challenges. My previous speakers has already given a detailed overview of the market size and all this. Just now, when we are compiling a booklet for what we have done in last 2 decades almost, we are seeing that the growth perspective, if you see as compared to other sectors of textiles, technical textiles has a rosy picture. In 2014 also, we were sixth largest in market size, but now we are fifth largest. If you see the growth rate, it was 5 to 6% at that time. Now it is around 10%. And we hope that in future, the growth will be more than 15% or so. And penetration level has increased from 5 to 7% to 10 to 12%. Penetration level, you can say that if you're using in any segments, say textiles, how much percentage is the technical textile? Like in medical textiles, in hospitals, you can have cotton normal bed sheets, but if you add the antimicrobial property, it becomes the technical textiles. So how much percentage you are using? This is indirectly a parameter of how developed your country is. In developed world, penetration level is around 30 to 70% different segments. India 10 to 12%. The vision of our Prime Minister to make country a developed world by 2047, when we will complete our 100 years of independence. So technical textiles penetration level will give an indicator how we are developing. It also depends on the well-being and purchasing power of our country also. So when we go, first we have to do the SWOT analysis. Opportunities are there. So first we have to see what our strength is. The strength we have already shown in the case of PPE kit. Within 2 months, we became the second largest exporter and producer. We had the largest youth population and a very strong base of education. We had, so this is the strength, and we have the strong base of laboratory scientists. Weaknesses, this weakness is very important. Technical textile, we had certain weaknesses. So lack of high performance fiber. I think many of the speakers has highlighted this. High performance fibers means aramids, ultra high molecular weight polyethylene. Only few companies in the world are having the entire share of this, and we are importing. And some may complain that we are having a heavy tax structure on imports. That is another aspect. So indigenous machinery, we are almost nil in machinery, especially technical textile machinery, except cotton value chain. We are importing almost every machine from the developed world. So we are lack of the machines. Skilled manpower, we don't have the skilled manpower, and we have the weaknesses in our education system. What Mr. Majumdar has very clearly laid down. So in the month of October, we had a detailed interaction with the alumnus and students of IIT Delhi with our Honorable Minister Piyush Goyal. And there are some important facts has come to our knowledge that the only IITs having textile engineering is IIT Delhi, and one NIT is NIT Jalandhar. Nowhere else textile engineering is there. Otherwise, it's only the state colleges, and very less equipped, you can say, and outdated version are there. One student of IIT Delhi, I think he's doing MTech or PhD. He had told that he had done engineering from a HOD college. So we are all shocked what HOD college means. He said in our college there was only one person. He was HOD also, and he was the faculty also. So this is the state. And BTech students, if we see the profile, only 5% of the IIT Delhi BTech students retain in textile sector. All are either going to the finance, IT, or some other sectors. MTech students are those which have done the graduation from small state colleges, and they got the opportunity. So this is the conscious decision of our ministry. We have written a letter to Dean IIT Delhi to consider increasing seats in MTech, not in BTech, unless until you restructure your textile engineering course at UG level. So we are also thinking to call a meeting with all the deans of all textile engineering colleges so that we can come up. And we had an interaction in that meeting. We have called the Department of Higher Education, AICTE, UGC also. So this needs that's a very valid point you have said that requires restructuring. In the industry captains were also there. They said that the skill set that they require, that colleges are not producing. This is the major weakness. Another is the awareness not there. Even before 1 year before, when I was not in textile sector, I was not knowing what technical textiles are. So awareness is not there, demand is not there. It is alternate construction material, like geotextiles is alternate to concrete metals. It can replace anything. You can say fibers are wonderful materials. So we have to create awareness. Fragmented value chain is there. India raw material is produced somewhere, spinning is done somewhere, and garmenting is done somewhere. So these are the some scale. Scale is the problem. So these are the some of the problems, and based on this, government has thought to bring a mission called National Technical Textile Mission. National Technical Textile Mission, basically, as you have mentioned, there are short-term solutions and long-term solutions. And TTM is based on very long-term vision, not the short-term vision. Short-term vision can be you reduce the duties and you do this thing, and that will immediately will help you. But in the long run, it will not help you. It is the vision of indigenization, you can say, creating our own strength. Creating own strength means we have to go for the research work. Unless until we do the research, we will fail. But someday will come when we will succeed, and then we at least one of our companies or all can develop institutions can develop some high performance fiber. So we need to invest heavily on this, and we need to invest heavily in development of the machines. So we have launched number of schemes. We have 1,000 crore outlays there. So far we have approved proposals worth 265 crores only. More than 100 proposals are in pipeline, which are under evaluation. So still the opportunity is there. The industry can be partnered with us and any of the research institution and can avail this facility. Machine development, yes, we are not getting any proposal from the industry, although we have allowed directly industry to take advantage on 80-20 basis. 20% has to be shared by industry, but I think it's not a very difficult task. Everybody is looking for the short-term easier path. Easier path is to import rather than investing heavily. India is the only economy, you can say, which has jumped from primary to tertiary sector. Manufacturing is totally missing, not only textiles, it's everywhere. We are from agrarian economy, we all are going in the services sector. Nobody is interested in doing the manufacturing. So nothing will come overnight. It requires a effort for many years, then only we can succeed. And research also, I am really failed to see that not very good research proposals are there. This is only the plus delta approach. I call the plus delta approach. Some research is there, you add some value and you submit the proposal and do the PhD. And we need to have some very good research, innovative research proposals of high value, because money is there. Unless until we develop a habit of doing the research, we will not succeed. Even private industries, they have to create their own setup for R&D. Yeah, I think many of you have gone to the Uniqlo. Uniqlo has developed a series called Heat Tech. You in the winters, you must have used the cloth. It is 5 times costlier than the normal body warmers, but still people are buying. This is the end result of research. Until companies do the research, technical textiles won't be possible without the research. You have to have a very robust R&D system within the company, and government is there to support. Mission cannot be forever. So this habit have to change. And startups, we are going to come up with a scheme to support the startups in technical textiles. Whatever research has been done to commercialize it, to take it to the TRL level 8 or 9. So we are going very soon. We will be launching a startup scheme so that the young entrepreneurs can take help of this. And this second component of the mission is market development. We are focusing market development segment wise. We are going like geotextiles, all the infra ministries. We have had a conference like sports tech. We are going to have a conference this and demonstration center for agrotextiles. We are establishing a demonstration center, a huge demonstration center where different type of cropping patterns. You can see that this is the some 500 square meter area. This is the cropping done with all latest technology, but without agrotech. This is with agrotech, and anybody can go and see how advantageous agrotextiles are. Then only farmers will use it. Export obviously the education I've already talked. We have launched. I'm agreeing with the Mr. Majumdar that at UG level technical textile curriculum has to be broadened, general one. At the same time, technical textiles, not textile engineering. So we have a 400 crore outlay. So we have launched a scheme wherein we are going to support the educational institutions for the setting up of the laboratory, training of the faculty. That means across the stream of the engineering, means civil engineering can have the 1 or 2 subjects on geotextiles, mechanical can have the industrial textile, even medical colleges can introduce subject on medical textiles, agriculture institutes on agro textiles. So we have received 36 applications which are under evaluation. We are going to support the colleges by giving grant to them to introduce these electives and mandatory courses in their existing curriculum. We are not interested in creating a separate course on technical textile, although it is welcome, but that it requires that all the UG and PG level, some inputs are there across the streams. Skilling is very important. Skilling requirement, we have formed a committee of industrialists only. Mr. Mohit Raina of Raina Industries is the convener, and Arvind and Mr. Lalbhai and 5-6 people fellows are there. I'm not remembering the name. So if you have any suggestions, you can come up, in which we are taking care of the skilling requirement of textile industry as well as user industry. In the technical textiles, you have to see the user industry also, like construction industry, using your geotextile, building textiles. So you have to take care of the skilling requirement of that also. FTAs are very I think within with many countries, FTA will come up very soon. That will help the problem, solve the problem. And standards, I think Mr. Basu has very much laid emphasis on that. We have more than 510 standards in technical textiles, and last year we had a conclave on standards. So this year also we are going to have this. If any further standards are required, HSN codes, QC or quality is very important. Technical textile, there cannot be any compromise on quality. On conventional textiles, you can have compromise on quality because it is only aesthetic purpose. But in this protective clothing, if it bulletproof jacket doesn't perform its function, it will be cost to the human life. So industry has to come up with within certain quality. That is why we have introduced the quality control orders, in which BIS has got certain powers. It is a mandatory certification. There may be differing views. Some may agree that, some may say that the QCOs will not be in the interest of the industry for the time being. But technical textiles, we are going for the QCOs in a big way. So in the future, we can go for this. And I think I've covered almost everything. And this PLI scheme, I think many of the industries have taken the advantage of this. Prime Minister, mega textile parks are coming up. 7 such textile parks has already been announced in 7 states. They are going to be set up in more than 1,000 acres of the area with plug and play facilities, common facilities like common CETP, common even you can think of common dyeing facilities also, so that competitiveness can increase. This is the advantage that industry can take up. And with this, I end my words. Thank you to everyone.
Thank you so much, Mr. Rajiv Saxena, for pointing out the concerns one by one and answering all the relevant information when it comes to the government participation in the industry. We really thank you for that, sir, and thank you so much for taking out time. And before we call upon Mr. Rajiv Vik, we will be doing the unveiling of the reports, and then we'll be giving letters to our esteemed president of the dais, starting with the guest of honor. So we'll be making the report as of now. Thank you. Thank you. So I would request Mr. Madhusudan Bagaria, Chair, PhD CCI, and Mr. Rajiv Vik, Co-Chair, Textile Committee, PhD CCI, to give a planter and memento to our guest of honor for the day, Mr. Rajiv Saxena. A big round of applause, please. I think it was one of the most informative sessions that we had. Again, I would request Mr. Madhusudan Bagaria and Mr. R.K. Vikji to kindly give a memento to Professor Abhijit Majumdar, Department of Textile and Fiber Engineering, IIT Delhi. Up next, Mr. Nandan Kumar, Director, High Performance Textile Private Limited, please. So, Mr. Mitch, please, I would request you to please join in as well. For two more people to go, sir. Dr. Arindam Basu, Director General, Northern Indian Textile Research Station, sir. Thank you so much, sir. Now I would request Mr. Rajiv R.K. Vikji to kindly give a vote of thanks, please. Thank you.
सर्वशक्तिमते परमात्मने श्री रामाय नमः। सर्वशक्तिमते परमात्मने श्री रामाय नमः। सर्वशक्तिमते परमात्मने श्री राम। हमने उस ईश्वर का नाम लिया। हम इस सेशन को आखिरी पड़ाव पे ले जा रहे हैं, उसका बहुत बहुत धन्यवाद कर रहे हैं। बिना किसी रुकावट के ये हमारा सेशन पूरा होना जा रहा है। सो गुड आफ्टरनून माय डियर फ्रेंड्स. On behalf of PHDCI, I have been asked to place vote of thanks. मुझे जब राकेश जी ने कहा कि आपको वोट ऑफ थैंक करना है, तो पहले तो मैं हिचकिचाया। मैंने कहा मेरे से स्पीकर का काम करवा लीजिए, वोट ऑफ थैंक्स का मैं नहीं करना चाहता। वो कहते कि क्यों? मैंने उनको कहा कि वोट ऑफ थैंक्स करना तो अच्छा लगता है, पर इसमें कभी कभी गड़बड़ हो जाती है। तो एक बारी मैं टेक्सटाइल एसोसिएशन, आई एम ए प्रेसिडेंट ऑफ टेक्सटाइल एसोसिएशन ऑफ इंडिया, तो मुझे मुंबई में बुलाया गया। बहुत सारी कम से कम 300-400 डेलीगेट्स से वोट ऑफ थैंक्स के लिए कहा गया। मैंने सबका नाम लिया, परंतु बाद में एक नाम छूट गया मेरे से, तो वो नाराज होता रहा। वो आज तक भी जब मिलता है तो बहुत प्यार से कहता है आपने उस दिन मेरा नाम नहीं लिया। तो इसलिए अगर किसी का नाम छूट जाए तो वो चुपके से इशारा कर देगा। तो थैंक यू। I thanks Mr. Rajiv Saxena ji, guest of honor, Joint Secretary and Missions Director, National Technical Textile Missions. I thanks Professor Abhijit Majumdar ji, Department of Textile and Fiber Engineering, IIT Delhi. I thank Dr. Arindam Basu ji, Director General, Northern India Textile Research Association. I also thank Mr. Nandan Kumar ji, Director, High Performance Textile Private Limited. I thank you, Mr. Madhusudan Bagaria ji, Chairman, PHDCCI Textile Committee and CMD, Filatex India Limited. It's my privilege to listen to the eminent speakers. We must say this is an excellent session, which is very informative, that gave all of us an opportunity to listen to the views of the eminent speakers. We are happy that during the session, we have touched upon several pertinent issues of technical textiles and other concerns and challenges. During the upcoming sessions, innovations, possibilities, and the ways forward. I thank to all my members and delegates and students for being part of the session. I'm sure that the session is very fruitful for all of us. Just as Saxena ji said, as Basu ji said, technical textile is a very growing area. We are in my association, there are very big industries are there. They are just asking one thing. We are ready to put the money. Please tell us where to put the money. Give us some project report where we should get the return. Even in these days today, FD, we get return of 8%. If you are ready to give us the return of 11 to 12%, we are ready to give us. So my request is that small project we should be given, and there should be slightly the comfort, assurance should be there that at least we'll get some of the benefits also. As Saxena said, my younger son also, after doing a 10-year service, went to some technical textile of innerwears. He started using bamboo fibers, micromodal, another thing, very costly, just like Uniqlo. He said first 3 years were very difficult for him because he was not getting where to get this innerwear tested. But after 3 years, he just managed. Now, touch wood, he's doing well. I also congratulate the PHDCI export committees of textiles, expert committees of textile for this wonderful initiative that we will surely continue for the larger benefit of the textile sector. It is also my duty to thank Ministry of Textile, our associate partners, Imagine Fibers Private Limited, our knowledge partners, Fiber to Fashion, and our academic partners, Department of Textile and Fiber Engineering, IIT Delhi. I would like to mention that the textile business in India faces significant obstacles. More cheaper quality of import of some filament and fabrics are coming in India. I am of the opinion that Indian textile sector will achieve to the tremendous heights under the leadership of our respected Prime Ministers, our Textile Minister Piyush Goyal ji, and our State Textile Minister Darshana Banerjee, which knows about textiles in and out. Textile industry needs adequate assistance from national and state government to its small and larger units. With these words, I would request you all to accept my vote of thanks and wish you all good, healthy, and stay. Friends, before I conclude, my thanks for joining duty. I also thanks the reception peoples who have managed so well, and the house is totally full. There are people are standing also. My thanks to the security which have managed this show very well. अभी मुझे इशारा मिला है इस साइड से, 3 आदमी देख रहे हैं कि हमारा नाम नहीं लिया गया। ओ मयंक जी का मैं नाम लेना भूल गया, रिसेप्शन जिन्होंने सारा ये वो किया है। और उधर वो घंटी बजाने वाले भी कह रहे हैं अगर आपने मेरा नाम नहीं लिया तो मैं आपकी घंटी बजा दूंगा। तो और फिर मेरे लेफ्ट हैंड साइड जिन्होंने इसको बहुत अच्छी तरह माइक को संभाला और अच्छा किया, तो मैं सबका थैंक्स करता हूं। तो वंस ऑफ ऑल थैंक यू एवरीबॉडी, थैंक यू वेरी मच।
Thank you so much, sir. Before we disassemblate, I would request everybody to kindly stand for a good photograph and also join Mr. Madhusudan Bagaria and RK Vigji to give a memento to our guest of honor for the day as well, please. Thank you.
Thanks.
Thank you. Thank you
very much.
Thank you all the speakers. Now we'll be starting with the second session.
Thank you, sir. Thank you so much. Thank you for joining us, sir.
Thank you. Thanks.
To start with session 2, please allow me to call on stage Professor B.S. Request you to kindly settle down, please. Request everybody to kindly settle down, please. Thank you. We can start with this session. My humble request to everybody to kindly settle down, please. We'll be starting with the session 2. Sir, वो बोलूंगा तो 5. Please settle down. Thank you. Okay. So we are starting with this session 2. Please allow me to call on stage Professor B.S. Butola, Department of Textile and Fiber Engineering, IIT. Mr. Uma Shankar Sinha Mahapatra, Managing Director, Fulkara Chemicals India Private Limited, affiliated to the Fulkara Chemical GmbH, Germany. Mr. Shashir Tyagi, Deputy Director, Wool Research Association, COE, Sportec. Mr. Yati Gupta, CEO, Fabiosis Innovations Private Limited. Dr. Anasuya Roy, Founder, NanoSafe Solutions Private Limited. Dr. Ajay Kumar, Chemical Department, Sharda University. I request everybody to kindly join us on stage, please. Thank you. Request everybody to kindly settle down, please, and maintain silence. Thank you so much. Sarthak, yeah, please can you come on stage?
सर 10 मिनट की है तो एग्जैक्टली 1 मिनट पहले बचेगी
Please settle down. We are starting with the second session now. Request you to kindly maintain silence. Thank you. So again, once again, we welcome all of you to the International Conference on Technical Textile. And now we'll be heading towards the second session, starting with Professor B.S. Butola, Department of Textile and Fiber Engineering, IIT Delhi. So I would request everybody to kindly keep their mobiles on silent. That was one of the issues that when we started the inaugural, most of the mobiles were ringing, and I would request you kindly maintain silence so that we can start. Over to you, sir. Thank you.
Very good afternoon, everybody. This is Dr. B.S. Butula from IIT Delhi. And I am going to make a presentation on disentangled polyethylene tapes for impact resistance applications. This work was done by our student Mukesh Bhatia and Dr. Abhijit Mujumdar, who gave a presentation in the first session, was also there as a co-supervisor. And this was actually a kind of funded research where RIL supplied the material also, and they also partly funded the scholarship of Mr. Mukesh Bhatia. This topic was specifically chosen because in the morning, Mr. Bagheria said that the technical textile industry suffers from, the procurement issues. So right now in India, most of the high performance materials are being imported actually, and we all in the industry and academia, we understand that this is a serious situation where we have to, depend on the outside agencies for supply of these raw materials. And this particular project, this raw material, which is we are calling as a disentangled polyethylene, was actually developed and supplied by Reliance Industries Limited, and we have published some papers on this, and that's why I'm showing it here. So basically, we work in the area of bulletproof textiles, and this is the history. You can see the first generation in around 1900 was made with silk, and then we gradually graduated to nylon, and finally in 1970s it was aramid. Nowadays it is being replaced by ultra high molecular polyethylene, which is similar in performance but almost 30% lighter in weight. And because weight is a very significant factor in bulletproof jackets, this material is being used mainly nowadays. However, all these materials, this Kevlar and ultra high molecular polyethylene, they are being actually imported. And whenever there is a crisis, for example, recently this Ukraine-Russian war has put a kind of constraint on the supply of these materials. So there is a dire need for us to develop some of these materials, and this one step where Reliance has taken a lead, and they have, you can see in this slide, this is para-aramid, this is PBO Gylon, and this ultra high molecular polyethylene, which is basically a long molecular weight version of polyethylene. Now the thing is, the molecular weight is so high that it cannot be simply processed by melt spinning. So it has to be done by use of solvents which are very toxic, and this is called gel spinning. Now the DPE, this is disentangled polyethylene, is another form of ultra high molecular weight polyethylene, but because the molecules are not entangled, it can be processed without the use of solvents. So this is the biggest USP, that you don't use toxic solvents, and then you don't need to remove them also. And this is a typical design of a bulletproof jacket, which has a panel made with some layers which are called as strike face, which maybe you can say this ultra high molecular polyethylene or this Kevlar, and then there are some backing materials which are required for reducing the trauma. Now this disentangled polyethylene is made with the same kind of process. The difference is that you use a different kind of catalyst, and the major knowledge is basically the use of proper catalyst. So using a proprietary catalyst, you can create a polyethylene which is where the molecules are not entangled, and you can use the process of sintering or high temperature to create structures which are just like ultra molecular polyethylene. Now this is a recent phenomena, and you can see the activity has started in the last 1 decade or so, and you can see the patents and publications are few, but this is a field that has a potential, and at least in this area India has a lead. This is that the material is being manufactured, and on the basis of the work that Mukesh carried out, the Reliance has planned to, move in a big way on this area. Now, what is done in a general process is this is the normal process. You have a gel spun filament, and then you make a sheet and you create a what we call is a unidirectional laminate, and then you combine a layers of them and to produce a panel where the fibers are arranged in a one direction. On the other hand, when you have this disentangled polyethylene, what you can do is you can simply sinter it. You can produce it through pass through it heated rollers and just draw it. So this was the material that was supplied by Reliance in the form of highly drawn tapes, which we use for the research. So you can say that this tape was drawn in different zones, and in the final zone the tape was highly drawn, and this is the shape of the tape that you can see here. And what was done in the research was basically we created laminates and then evaluated them. This is our testing range, and the process that Mukesh followed was it's very laborious process, but Reliance is trying to mechanize this into a large scale. So what he did was he took a sheet of LDP and then laid out the tapes in one direction and then in another direction, and then he put some amount of some layers at different angles 0, 90, and then covered them on top and bottom with the LDP sheet, and then heated them in a you can say compression molding machine to come up with a cross ply, what we call as cross ply laminates. Now to compact it in a form of a laminate, what you need to do is you need to use a temperature which has to be very precise, because a temperature which is much lower will not be able to compact, and a temperature higher than the optimal temperature will result in the melting of the filaments or this sheet, which will lose the properties. So once this was done, these panels were tested in our lab in what we call is a dynamic impact tester, and finally in a bullet testing range in the TBRL, which is a DRDO lab. And these are the properties. So what is being shown is the tape property here, linear density. This is we also compared with the conventional filaments which are available in the market, and then with para-aramid, which is Kevlar basically. And you can see that when they were tested for tensile strength, because this is one of the parameters which determines the ultimate performance of the panel. They all of them basically you can say they perform almost similar. Okay, so this material that was developed had properties which had the potential to be developed into a bulletproof jacket, and this shows the properties of the laminates with different layers. So what Mukesh did was he used 2, 3, 4, 5 different set of layers in the laminate, and one laminate he prepared with a woven fabric. So this is the last one, and then he tested, and you can see that as you increase the number of layers, the strength actually increases, because the content of the LDP that was used at the top and the bottom goes down. And these are the tapes which you can see they were after testing. This was how it was looked, and the tapes were, or you can say laminates were prepared at 2 different temperatures, 125 and 135. And then they were tested on a dynamic impact tester, and you can see these different graphs show different performance. And this is for 2 layer, 3 layer, 4 layer, 5 layer. In this direction, the amount of LDP reduces, and you can see the performance improves as you have more number of layers. And this is about the force. Now, this is a dynamic impact testing of different structures. You can see that the energy absorption on this side increases with the number of layers, which is obvious, but this was normalized, so it can give you the effect of different layers. So this was tested. You can see this when there are 2 layers, 3 layers, 4 layers, 5 layers. The impactor is able to penetrate. In 5 layers, this is stopped. But you can see the fibrillation of the tape at 125 degrees centigrade. And when you have 135 degrees centigrade, the energy absorption was higher. And you can see the melting also. This is the fabric based laminate at the same construction parameters, and it fails. Now these are the results for bullet testing. Actually, the bullet speed was something like 430 meters per second, and you can see that the fabric made with this woven Kevlar, it has got perforated. The area density was 4.6 kilogram per meter square, and when you had a panel which was made with the disentangled polyethylene tapes which are supplied by Reliance, this stopped the bullet, and the trauma was 22.3, which is less than the required trauma of 25 mm for Indian forces. And you can see the bullets get damaged, and you can see that this is a perforated panel, and you can see these bullets are stopped, and this is the trauma. You can see here, this is less than 25 mm. And this is the analysis that we carried out. I'm not talking about this. And what we can see is that this was the work in the last line, and you can see that the aerial density is quite low. This is less than 5 kilogram per meter square, and it was able to stop the bullet. Not only stop the bullet, it was able to give a trauma of less than 25 mm. So what these are the publications that came out of this work, and we were also able to file one patent. And I would like to thank these agencies. One is DRDO, which was instrumental in testing the panels. RIL Baroda for funding this scholarship as well as providing the samples, and FICCI is also funded part of the research. Now the conclusion is that it is possible to use indigenously made material for developing bulletproof panels. So thank you so much.
Thank you so much, sir, for the quite informative presentation. We came to know a lot about the fabric structure, specifically when it comes to the bulletproofing. Okay, moving on to our next speaker, Mr. Uma Shankar Sinha Mahapatra, Managing Director, Pulcra Chemicals India Private Limited, affiliated to the Pulcra Chemicals GmbH Germany. Over to you, sir.
Hi, good afternoon, everyone. So I represent chemical industry which are used for textile, including technical textile. But to give you a background, I spent significant part of my career into technical textile, almost 8-9 years, which Dr. Nandan was referring to in protective textile. So I had the opportunity to do a lot of those at the early years. So first time Nomex in India, Proban, which is a THPC-based chemistry, also first time done in India. So I was part of all those projects long back. So I can relate to those applications and how chemical can support some of the conventional material to convert into technical textile, because there are a lot of opportunities. There are material available within our reach. So there are possibilities by, by doing some functional treatment or using right additives, we can convert those into technical and very specialized applications. So that will be my focus of today's discussion. So introduction about the group application specific. I will focus my discussion towards synthetic fiber and nonwoven application, and nonwoven to be more specific to hygiene application and medical application, and some of the bio-based functional finishes which can find application in protective textiles, home textile, those kind of areas. So Pulcra is having a history over 145 years. Basically, this is a Henkel company which spun off their industrial business, B2B business related to textile and leather to a company called Cognis. And later on, it became Pulcra for last 25-30 years. We are headquartered near Munich, and we have factory in India, a place called Tarapur near to Mumbai. Present in 16 countries across the globe. Most of the places we have our plant, including in India. And also we have the production, along with the production, we have the full R&D facilities, application and lab facilities. So this is the headquarters near Munich. And we primarily cater to three segments: textile, fiber. By fiber, we mean the extrusion of synthetic fiber and the downstream spinning, leather tanneries, and also some of the performance chemical for primarily for paper and furniture industries. 2 years back, we took over a company called Devon from Belgium, which specialized in bio-based functional finishing. So this is also having a history of 45 years into functional finishing. So Pulcra is present across the value chain of textiles, right from the primary spinning of fiber to the final finishing, except dyes and pigments, but we support auxiliaries for dyeing and printing as well. So today we'll focus primarily on primary spinning and secondary spinning, and at the end of the value chain, which is the finishing. So fiber activities can be, because a lot of technical fibers is not easy to spin, as Dr. Nandan was referring. Although the fibers are available, we have enough spinning capacity in India, but you need a special treatment to treat all these functional fibers. Because sometimes this could be really very brittle, sometimes it could be really strong to handle in a traditional drafting zone of spinning machineries. So you need to have a, although you have equipment, you have the fiber, you need some additives. So we support, spinning all those performance fiber by giving a additives in terms of fiber finish, which is lubricant and anti-static properties. So spin finishes for filament and also staple fiber. So this is called, one is called the primary spin finish, which goes into the, while extruding the fiber, like Reliance or Birla, while extruding their fiber, they will apply those finishes. And also secondary spinning, like say all the ring spinner or open end spinner, they need to put certain finishes so that it can run at the right efficiency. So that is called the secondary spin finish. We also provide spin finish for non-oven application, because while doing the needle punching or spunlace, you need a different kind of treatment. Spinning mill we talked, especially the fibers like wool and aramid, those are really very tricky to handle, because that creates a lot of static charge. The application could be in the various kind of polymer base, including polyamide, polyester, polypropylene. Polypropylene is again a very tricky fiber to spin, because a lot of polypropylene is being used in filtration application, and also it is very highly chemical resistant. So polypropylene also find application in our domestic water filter. Sometimes we don't realize, but the first cut is in our domestic RO is a polypropylene, open end yarn, or sometimes drape spun yarn. So there are some material we are using day-to-day life, but we don't realize. So polypropylene is a tricky fiber which we support in terms of giving the right finish. And in India, we have a very limited polypropylene staple fiber manufacturer. There are many polypropylene filament which goes into application like say filter bags, or even sometimes into your narrow width tape. But staple fiber we have limited application. We are the one of the main supplier for fiberglass roving spin finish, which is again a very tricky fiber. So companies like Owens Corning, they will be using our spin finish. So across application, including apparel, technical, automotive, geotextile, hygiene, and medical, these find application, because you need different compliances to apply for those kind of application. For hygiene and medical, you need a different compliance certification. So some of the key markets we cater is the polyamide filament, because we don't cater the commodity polyester virgin staple fiber, which is almost like a commodity. So we only focused on specialized, fiber industries. Polyamide is one of them. Polyamide 6,6, which goes into airbag application. That's again a very few spinning facilities in India. It's primarily being imported, but we have the downstream process now coming up. We have also, very specific application for man-made cellulosic fibers. This is one of the premium product. Almost we hold 80 to 90% market share for diapers, feminine and baby diapers. The top sheet of the polypropylene is treated with pulchra hydrophilic finish. Other hygiene application and also composite industry, especially rubber reinforced composite. So some of the application, carpet is primarily made out of BCF filament. So this is a little bit different from our regular POI, FDOI. You need a BCF filament. So we have some facilities near Panipat. Sportswear is again a segment which is really lucrative. Most of the sportwear like Adidas, Nike or Decathlon might be retailing in India, but these are either fabric is imported or the whole garment is imported. So this is an area where there could be a lot of opportunity, and India is having a really skill gap also, because we have all the facilities. We have polyester filament, we have the knitting basin, but we can't handle 100% polyester filament based textile. So this, we need a real competency development in this field. You find a lot of fiberglass material in the windmill and other composite application. Many other textile you can find in automotive, and we support in terms of chemical additives in many of such applications. We also provide master batch, and not the master batch for doing the color, but master batch for adding the functional properties, like converting polypropylene into dyeable grade polypropylene, or say polyester, standard polyester converting into a flame retardant polyester, so that Dr. Basu was referring that now a lot of compliance is coming, that all the public places you need flame retardant. So if you do the topical treatment, the durability may not be good enough. So inherent polyester could be the solution for all these textile used in public places. We also do antimicrobial in polyester and polyamide. So I will talk about this hygiene application, which is really flagship product to convert hydrophobic polypropylene spunbond or SMS into hydrophilic. So this is the typical structure of baby diaper or adult diaper. So we apply our finish into the cover stock, most of the time on the cover stock, and maybe in some cases into the acquisition and distribution layer, the second layer. Then you have the absorbent core, and the bottom layer is the breathable, flexible back sheet. So this is basically to improve the hydrophilic properties, but at the same time you need to meet certain compliance requirement, because this is next to the sensitive skin. So you need a FDA and other regulation compliances. So very stringent testing, because sometimes for baby it's very stringent that we need to give assurance for 12-hour leakage proof or those kind of things. So we need to do very stringent testing, which is called strike through, and also the runoff properties. So these finishes help to achieve all those critical performance parameters. So along with the hydrophilic properties, we also bundle with the cosmetic effect. This could be a active ingredients like aloe vera, also vitamin E, olive oil. So this may be customized, and sometimes it can be also combined 4-5 finishes together, so that we really take care of very long time, like say adult diaper, or sometimes for patient, they need to have a very long use of certain diapers. So there should not be skin irritation or those kind of things. So this helps. We also have, so those finishes are applied at the spunbond or SMS fabric manufacturing stage, but we also have chemical solution which can be used during the converting stage, like say roll goods to diaper conversion. So we have a special Belsoft care lotion, which is again a very good for skin. So you can have a standard non-oven, but you apply only need based for a certain particular brand of yours with the Belsoft care lotion for the skin related improvement properties. So Devon Chemicals specialized in either bio-based or biodegradable. Whatever they are doing, they are either be falling under this category, bio-based or biodegradable. The application areas are performance, thermal regulation, protection, and also health and wellness. Also, we have the technical textile flame retardant coating. We don't cater to the clothing for protective textile, but we cater to all other applications like carpet, including the aerospace. We have the certification for Airbus for the aircraft carpet coating. We have a very specialized range for medical cotton. This could be another area where a lot of consumption happening, and India is primarily still small scale industries we have. But there are very large scale industries in Turkey, US, and also in Pakistan. They supply bleached cotton to all spunless nonwoven industry, and also for converting into the consumer products like the makeup pads or cotton balls or medicated cotton. So this area is another area where investment is possible in medical textile. And we offer a very flagship product called Cetilon Cane, which is used across the globe to give a very crispy feel to the cotton. Otherwise, cotton will be very limpy and it will stick to the skin. So this helps to have a withdrawal of the bandage more or cotton more smoothly. Some of the products, bio-based products from day one, antimicrobial, which is bio-based, a softener, which is bio-based. Then you have the phase change material, which can be thermal regulating properties. It can goes primarily into socks or, so home textile. A lot of very, where you need to improve the comfort properties of textile, this kind of finishes can be applied. We also have a range of very exotic aromas like camphor or amaranthe or those kind of things can be infused as a micro capsules in the textiles. We are working on bio-based flame retardants, although that's little early stage. But all those, flame retardants, although Dr. Basu told it has to be in the baby clothing, but we need to be mindful. Most of the flame retardants are highly toxic. Most of the cases, these are having a very high formaldehyde content. So we need to be very, very selective in terms of selecting what kind of flame retardants to be used, especially for babies. So it's very, difficult task. So even if government comes with a legislation, it can create a chaos in the market. So we need to be prepared before we, issue such kind of guidelines, whether we are really ready for catering this huge market and this population in India. We also have a, bio-based, which is a probiotic-based anti-allergen products called Purizimo, and other functional properties like fluorine-free water repellent and fluorine-free stain release properties. So some of the application of Biome is our trade name, Biome Natural, for antimicrobial application. Hermic Bio is the phase change material, so it converts from solid to liquid and liquid to solid depending on the temperature fluctuation. And Move and Cool is a very unique product for sports clothing. All synthetic fiber applied with this finish can be very durable, hydrophilic at the same time, and also it will dry faster, which is the main properties required for sports clothing or outdoor clothing. And this concept was endorsed by Belgian Olympics team in some of their jerseys. Few other active ingredients we provide under the brand name of R Vital. So thank you for your kind attention.
Thank you so much, Mr. Umashankar Sinhaji, for such a fantastic presentation and giving us the fiber alternatives, as you mentioned. Moving on, we have Mr. Shishir Tyagi, Deputy Director, Wool Research Association, COE Sporttech. We're looking forward for your address, sir. Thank you. Over to you.
Thank you. Good afternoon, everyone. I'm Shishir Tyagi, working with Wool Research Association, Thane. We are Center of Excellence in Sport Technical Textile, which is one of the technical textile sector. So before going into the detail of this presentation, let me just brief about what is sport tech. You all know technical textile, the textile which are being known for its functionality rather than only the aesthetic appeal or values. So in sport tech, it has been categorized in three ways. One is sportswear, sports goods, and sports accessories. So sportswear, what we wear during any activity and which enhance the performance of the athletes of the wearer into the when we do some activity. They have some performance or functionality properties such as better moisture management property, dry rate, and antibacterial property. Another sports goods. Sports goods are basically those items which participate in the sports actively, like without which you cannot play a particular game, like football, rugby, hockey stick, because without hockey stick and ball, you cannot play the sports. And third is sports accessories. Sports accessories which provide you the requisite playing condition. It enhance the feel of the person. Like if you have an artificial turf or net, then the playing condition would be much better. So I'll not go into the global sport tech textile market because it's already available in the public domain. Just for your views, like the market of this sport tech has been accelerated and growing around 13% CAGR. And the contribution or the product wise distribution among the national and international market, you can see that the maximum share has been captured by the sports shoe or footwear components. There are some key sport tech players in this sector. And why they are key sport tech player? Because they are focusing on the innovation as well as the quality and the price. So I just skip some slides and just go to the directly. What is the need in the sport tech sector? So as a center of excellence in sport tech, we have visited these areas where the sports goods being manufactured. These are basically decentralized areas. And what we find out the gap is there are some gap and requirement. Then we have jotted down all these gap and requirement. First is wool nylon blended fabric for lawn tennis ball. Although we have expertise in rubber manufacturing facility, however, the felt of wool and nylons in 65-35, which need to be basically fluorescent in nature, because wool part is also there along with the nylon, so that is required. And still we are currently importing this item from Taiwan and Indonesia. Another is low cost 4-way stretch fabric for the sportswear. We have some gap in this area also, and generally we are importing this from China, Taiwan, and Indonesia. And current requirement is that the Indian manufacturer should come up with the competitive price in this 4-way stretch fabric as well as the technical know-how of the manufacturing technique. Another is dyed nylon 6/6 knitted fabric with good fastness property. There is also gap in this area, where is only limited supplier and which is also cost intensive process. So where the improvement can also be seek into this area. Another is manufacturing of seamless garment and its technical know-how. Basically, these machineries are being originated from Italy. There is a gap that we don't require much skill in this area, and the very limited availability of machinery, production process, and techniques available in India. Another is sports artificial turf. As per the international norms such as FIFA, Hockey Federation, etc. Currently, it is also an imported item, and there is no production and certification facility available in India. So, but the government is also focusing on this sector, such as under the Khelo India program, many of the this sport university come up with the artificial turf embedded grounds. And currently the consumption in India is 107 crore, which is totally imported item. Another is development of knitted technology for fabrics using yarn with higher lycra percentage. We are currently equipped with manufacturing up to 15% of the elastomeric yarn content, but above that, it's not possible currently because of the manufacturing setup in India. However, this has been very vital in especially sport tech products for compression garments, and as well as the garment which go into the e-wearables. Another is e-textiles for application in different areas. So there are many challenges in this sector. Like as you can see, the devices that have been utilized are not sturdy, they are fragile one, and they have short span time. They have poor reliability and washability, as well as they provide some noise and obstruction during the movement, as well as the addition of this device onto your actual garment. Another is gap and requirement in carbon fiber based lightweight sports goods product. There are some facility available, especially woven fabric based, but on the braiding technology, there is no facility available in India. It is totally imported item and there is no production certification facility available in India. However, they can be utilized like carbon fiber based lightweight sports goods can go into racket, hockey sticks, bicycle parts, and currently they are being imported item. So Wool Research Association was sanctioned by the Government of India, Ministry of Textile. We have some unique facilities which may be helpful to the industry, such as we have sweating thermal mannequin, which measure the comfort property of the wearer, and we can use it for measuring the comfort property of sportswear or any protective garments also. However, we do the testing for DRDO. We were one of their partner for extreme cold weather clothing system development indigenously in India. Otherwise, it was imported item. So all these things. There are some other facilities which may be helpful to the users or user industry, such as we have all the facility for testing of the sports garment and functional garments such as MVTR, hydrostatic spray test, and all this facility comes under NABL services. So we have all complete setup for thermophysiological comfort property, which measure basically the attributes towards moisture behavior as well as the heat stress generated into the fabric. So we have this comfort lab testing facility where we have all the sweating thermal mannequin, we have all the guarded plates like sweating guarded hot plate, dry guarded hot plate, we have Kava Bata evaluation system, all modules we have till KES7, we have moisture management properties for like MMT and dry guarded drying rate tester by Nike approved, and all these things are under NABL facility. Otherwise, we have also high visibility garment testing facility. Apart from testing facility and certification one, we have incubation activity also, where we have all warp knitting technology such as racial, tricot, and it's basically dedicated to the industries, technical textile industry, startups, or those industry who want to venture into some technical textile product pertaining to sport time. So we have like racial knitting machine where spacer fabrics, knotless nets, bandages, even fabrics in the medical textile, they can go into this area. Another is tricot where the sports wear, actually sports wear and lingeries, billboards, upholsteries, they can be manufactured over it. These are our international knowledge partner. So I'll just give you some development that we did. These are small development, but maybe any industry who want to diversify their products, they can look into these, like waterproof breathable rainwear. So basically, the technology is basically solvent-based technology currently available. But for going into the eco-friendly and green technology, we have utilized the water-based coating using the R-chroma chemicals. And then it was also been utilized not only in rainwear as an because of its antibacterial, soil repellent, water repellent property, but also in PPE. So we have prepared PPE kit in those COVID area, which were breathable, as well as which were reusable. Other is high visibility jacket, breathable jackets. So this was the PPE coverall that we developed a long time back, as well as we have set up testing facility for testing of the PPE and as per the NABL accreditation. This is another development. It is still TRL about 4, where we have developed and demonstrated a smart T-shirt for measuring the heart rate, ECG, breathing rate, calorie expenditure. So we have utilized these sensors to measure the ECG, and the sensors was incorporated during the garmenting itself, and the data can be directly transferred to the mobile application or any device through the Bluetooth. So if we talk about the cost comparison, there are some product available in international market which we imported, but this imported item is around 40 to 50,000 or a kit. However, our developed t-shirt is still 15,000, which is quite high. But as I said that we are still only at a demonstration level. If we want to scale up these things, then there is a chance that we can reduce the cost even about 4 to 5,000 rupees a kit. So we have validated this kit with the hospitals, then gyms, fitness centers, as well as we have tested this in Lakshmibai National Institute of Physical Education, Ministry of Youth Affairs and Sports, their athletes, international and national athletes, as well as Sports Authority of India, Patiala Center. Another is cooling jacket. So it's basically evaporative cooling based mechanism based jacket where you can reduce the temperature of the wearer about 4 to 5 degrees Celsius than the environmental. So skin temperature can be reduced. So you just have to use it, put it into the water, squeeze it, and you can wear it. So around 3 to 4 hours, you can feel cooling sensation. And it's very good for all those police personnel or who are have duty in their this sun or heat environment. So thank you.
Thank you so much, Mr. Shishir Tyagi, for giving us a presentation on the sports technical textile and the new technology being adopted. So moving forward, please allow me to invite Mr. Yeti Gupta, CEO, Fabiosis Innovations Private Limited, please, to take this forward. Over to you, sir.
So control L will be fine. No, control L. You can make it full screen. You can close the left tab. Yeah. The cross is there. Yeah. Yeah. Close it. Yeah, we should start. So hello everyone, my name is Yati Gupta. So first of all, thank you PhD House and the organizing team for organizing this such a wonderful conference. So there is technical textile conference is rare and I'm very glad to be a part of it. So let me introduce yourself to the company. So the company's name is Fabiosis Innovations and we specialize in medical textiles and we are a 4-year-old startup, still a startup. And we are sort of a vertically integrated startup, which means that we develop our own chemicals, we develop our own fabric, and we develop our own garments from these fabrics. And then we sell those garments to hospitals directly. So let me first tell you about the journey, how it has been. So we started in 2019. Okay. So, but we started working on it before 2019. That is around 1 year more. So 2018. So my journey in technical textile did not start with just the R&D part, where my journey actually started with a dire need. So I was visiting AIMS Delhi when I was a student at IIT Delhi. So we had some collaborative project, and I started talking to some of the patients there. So the one patient actually complained that when he got admitted to the AIMS hospital, he's actually now sicker. So I was very surprised to know how this can happen. AIMS is a very great medical facility, and when after admission, how can he get sicker? So after when I came back to IIT, I discussed with some of my professors and some of the AIMS doctors also, and they suggested me there is something called hospital acquired infections. So what happens is that when you go to a treatment facility, that facility is basically crowded with patients, and you know, if the public healthcare facility is there, the crowd is much more. So everyone basically touches everything. So there is a sort of rapid cross contamination. So that's how these infections like travel. So, but this was 2018. Let me say you again, because that was pre-pandemic age, and people were not much aware about these hospital acquired infections and cross contaminations. So what to solve this problem, we got to know that if we replace every fabric in hospital with a high performance medical textile, that is a textile having high performance antimicrobial functionality, the contamination rate actually reduces as much as 60%. So there are clinical trials and data which support this kind of claim. So we thought, why not develop this kind of fabric that can basically kill all these bacteria. So we developed that. That was in 2019. But then at the end of 2019, COVID came, and everybody was suggesting that why don't you make an antiviral fabric for the same thing? Because in the case of viruses, the cross contamination is even more. So we developed that, and then we also developed the antifungal fabric. Then we combined all these three functionalities in one single one. So now we have our innovation called Fabium, which is a high performance medical textile, basically that destroys more than 99.99% of microbes within 30 minutes of duration only. So 30 minutes of duration is very critical, because most of the medical textiles are usually tested with 24-hour standard. So I know the standard is there, it is ISO standard, but 24 hours is a long duration of time for any bacteria to infect you. So it's very critical that the time should be much less than 30 minutes. So microbiologically speaking, 30 minutes has also a different aspect that we will discuss later if possible. So after developing this fabric, we got a new challenge, that how to certify this kind of fabric, because remind you, it is 2018, and like people were like claiming that antimicrobial fabric is just antibacterial fabric. There was no concept of antiviral, and there were no testing agencies who used to do actually ISO 18184, which is the antiviral fabric standard. So fortunately now Citra does, and many other NABL lab does. Gradually labs started coming also. So now we have a fabric, this Fabium, which is antibacterial fabric, antiviral fabric, antifungal fabric, and it is also now free of formaldehyde, which is a major toxin if you use this fabric for babies or if for elder care, and also for the export purposes. And our fabric doesn't cause any kind of skin toxicity. So this was also a major challenge then, because people were developing these silver nanoparticles, and they used to coat these silver nanoparticles on top of the fabric. And silver and many other like metal nanoparticles have this sort of a skin toxicity. So what we developed, that there should be no nanoparticles in our case. So that was our major criteria. So we do not use any kind of metals, as you can also see here. So ours is a metal-free kind of antimicrobial, and we spent a lot of time developing that, honestly. So for the skin contact, we tested our fabric for 48 hours of duration, and there is no skin toxicity, thankfully. So we got supported from Department of Biotechnology, from the BIRAC scheme, and we also got support from Pfizer, a pharmaceutical company, and we are currently incubated at IIT Delhi, where we get incubation support and technical support also. Yeah. So here are some of the features of our fabric. Apart from all those bacteria and viruses, we also got our fabric tested for coronavirus and black mold. And our fabric can be developed into multiple colors, because the natural color of our finishing material is actually transparent. So any color and any print can be introduced on top of the fabric. And as I said, no metal toxicity or no toxic dyes were in our Fabium. So any kind of products can be made from the fabric. So when we develop a finishing material, you usually look into the application area. For example, master batches are for the polyester or polypropylene commonly used. But we wanted to make one finish that can be used on multiple kinds of fabrics. So our fabric, this formulation can be introduced on all kinds of fabrics, whether it is woven, non-woven, or knitted. So as you can see, these are the list of the products which are used in healthcare facilities that we actually sell. And we sort of renovate any hospital with these kind of products to make it sort of infection resistant. So, and we also got covered pretty well in the media because of at that time, if your fabric has the ability to destroy coronavirus, it was a huge thing that time. Now I think it's getting common day by day. So what next? So I'm using this platform to launch a new kind of product. Yeah. So this is actually the chemical that I'm trying to launch. Yeah. So this is Fabium Fresh chemical. Okay. So freshness redesigned, it is our tagline. So what it is basically a high performance anti-odor chemical that can be used for sportswear, innerwear, or home textiles, towels, and footwear applications. And here are some of its features. So anti-odor fabric can be made from that, which is highly durable. Right now, the anti-odor fabric has one weakness. Whatever is developed, whatever is available in the industry, is that it's not long lasting. Even after like 5-10 washes, the functionality is gone, and anti-odor capacity is not actually there. It is for the namesake anti-odor. So ours is the kind that 50 plus washes we have tried, and durable washing fastness is there for the anti-odor property. As you can see in the picture here also, the left the tube that is it is contaminated with fungus, and the fungus has grown on the fabric. And for the right side, there is anti-odor material which has resisted the fungus and also the bacteria. And it is sustainable, and it can be applicable on all fiber types, just like cotton, just like the Fabium. And we are also certified from Citra, and we have also some samples more from NABL testing labs that we have sent. We will receive certifications in due course of time very soon. So thank you so much for giving me the time. This is my contact address.
Thank you, Mr. Yeti Gupta, for a wonderful presentation and showing us the innovation at Fabium along with the Fabium Fresh. We really wish you all the best with that too. Thank you. Moving on, we have Dr. Anasuya Roy, founder, NanoSafe Solutions Private Limited. Over to you, ma'am. Look forward to you.
We think we are done with the pandemic, but the pandemic isn't done with us. COVID has left us with long-term impacts, including the likes of respiratory fatigue, long COVID symptoms, etc. I'm Dr. Anasuya Roy, and I head a startup called NanoSafe Solutions. We are incubated at IIT Delhi as well as IIM Lucknow, and we have a powerful antimicrobial technology based out of active copper, which can stop the growth of any kind of microbes. I think I compliment Yeti here because he's working on an organic formulation, and we are a metal-based formulation based out of active copper, yet very safe and sustainable. I'll talk to you about how it is safer and sustainable during the course of my presentation. So what I'm going to do here is I'm going to start with the basics of technical textiles. So technical textiles are, but of course, materials that are focuses primarily on technical performance, and there are 12 segments of technical textiles. The global technical textiles market, of course, has been emphasized to be growing rapidly from the morning as well, and Asia Pacific is leading the growth. The average CAGR is about 5.2%, but we see Asia Pacific region has a higher than average CAGR of around 6%. The domestic textile market is ripe as well. We are the 5th largest in the world. We have a good revenue. The growth rate is about 8 to 10%, and the government is accelerating the growth rate to be about 15 to 20%. And technical textile accounts to 15% of the entire textiles and apparels market. The key growth drivers which drives technical textiles market is demand from new application areas, which stems from innovation in this space. Sustainability and climate change, but of course, are very important sectors that technical textiles need to focus upon. And government related schemes such as NTTM, PLI are all fueling the growth. So coming to Meditech, because that's where most of our innovation lies, Meditech holds 7th largest position in technical textile segment in terms of application, with a CAGR of more than 4%, which is quite high. So defining again medical textiles, these are textiles used in human hygiene, healthcare, and medical applications. So that applications of medical textiles can be versatile. It can range from artificial kidney or artificial liver, very crucial application out there, but to a very simple face mask, which is a very simple yet complicated technical textile product that found profound usage in the COVID-19 pandemic. Now, when we are talking about face masks and PPE as materials to combat the COVID-19 as well as other kind of viruses, we should keep in mind that these are microbes, and we do have antimicrobial technology that can combat or stop the growth of these microbes. We might not have realized, but our daily life objects are frequently coated with generous amount of microbes that the naked eye cannot see, and these microbes can cause life-threatening diseases. Of course, COVID-19 has been an eye-opener for all of us, right? So antimicrobial textiles market, medical textiles market is also booming. There is a huge growth in this area. And if we look at the different kinds of antimicrobial materials that are used to make textiles antimicrobial, there is more than 44% usage of metal and metal-based biocides. The reason why metal and metal-based biocides are rampantly used still for antimicrobial effect is because it has very high efficiency, and this efficiency is difficult to match. So even though they are toxic, and the key companies who are dealing in this area, dealing with medical textiles or antimicrobial finishes are listed here. So what we have done at NanoSafe, we do cater to the metal and metal-based biocides antimicrobial chemistry, but in a slightly different way. What we have done is we have invented a technology called active copper technology, which is a very powerful technology to combat all kind of microbes. So if you look at other antimicrobial technologies, I think Yeti has also highlighted, most of them are antibacterial, but they claim antimicrobial. So that is something that the industry has been doing for quite a long time now, and that needs to change. So what we have done is we have created something that can combat all 4 microbes. It's a 4-in-1 technology with activity against virus, bacteria, fungi, as well as algae. And the USP of active copper technology, ACT, is the fact that it is also a micronutrient technology. I do not see antimicrobial technology out there, which is actually a nutrient on one hand and has excellent antimicrobial capacity on the other. So traditional science have always advocated the use of copper for purification of water or purification of edibles. And what we have done is we have taken that simple concept from traditional science and have engineered the active copper in such a way so that it has profound antimicrobial effect. Let us look at how metal-based antimicrobials work. So there is a consensus that metal-based antimicrobials release metal ions over time through a dynamic effect, and these metal ions interact with the outer envelope of the virus or the microbe or the bacteria, and there exists an electrostatic interaction. Once the microbe or the ion is together, what happens is the ions punch holes in the membrane or the envelope of the microbe, does some reaction there and enters the cell. And once it enters the cell, it generates ROS. ROS is reactive oxygen species. It's very reactive, reacts with all the proteins and kind of denature the entire cell. So if you look at the mechanism, you will realize that this is a multi-pronged approach. The ion does not only creates a barrier to the microbe, but also does multiple things at the same time, all within a very short span of time to create this effect. And therefore, that is why metal-based antimicrobials are kind of very effective in killing microbes. So again, looking at a comparison, of course, silver is a very natural choice in case of metal-based antimicrobials. The effectiveness is there, but what it lacks is perhaps it has very high toxic effects, and the toxic effects of silver has been documented and patented quite a lot in public literature. Yet silver continue to be in usage in antimicrobial effect. What we have done here, we have made copper our natural antimicrobial active agent, and it has excellent antimicrobial activity coupled with toxicity and sustainability. And sustainability is one thing that I think we are all aiming for in the coming future, which is very, very much in demand. A case study about the NSAFE mask. So what we did in the pandemic back in 2020, in the first lockdown, we launched a mask, which is a fabric mask with all the layers treated with our active copper technology. And this had just a lab to gestation period of just 15 days. Within 15 days, we identified the fabrics, we coated the textile material with active copper, and we have also checked the activity against different kind of microbes. So mask that we have created is active against the coronavirus as well, SARS-CoV-2 virus to be precise, via modified 18184 method, and it has shown good, excellent antimicrobial activity. So masks are not only about antimicrobial activity, the filtration also has to be taken into account, and we have taken into account the golden standards of filtration as per N95 standards, and we have kind of achieved that as well. So speaking about NanoSafe and what work we are doing in other verticals, so we are also having different verticals in plastics, paints and coatings. So our active, our portfolio is quite active in plastic and polymer domain. So we have active copper master batches, which can go into any molding application, be it roto molding, blow molding, injection molding, etc. It can also go into the non-woven fabric sector as well. And our best-selling product is a master batch which has been loaded with 40% of copper and can turn any kind of application, any kind of plastic application antimicrobial. Apart from that, we have copper-based nanomaterials as well, which can be used in paints and coatings and textile formulations and finishes that can cater to wide variety of fabrics, woven, knitted, or non-woven. The one breakthrough innovation perhaps that we were able to achieve at NanoSafe is the fact that copper has an inherent brown tinge, and which makes incorporation of copper in different products a little unacceptable because of the brown tinge. What we have done is we were able to curate a completely colorless copper, which can go into fabric, which can go into plastics. Even in the molding applications, we are able to have purely white copper as the end application color. Some of the products that we are actively working on, as you can see, there are many water contact applications. So we are operating in, water tanks, water purifiers, water pipes, a lot of water contact applications, and copper as a material has found widespread usage in these applications because it is generally considered to be very safe and sustainable. Yes, and miles to go before we sleep. So we are proud to have received many awards and accolades by the Government of India, the recent one being National Tech Excellence Award by Department of Science and Technology, TDB. And yes, so we do aspire to become antimicrobial pioneers and do aspire to promote our antimicrobial technology based out of active copper to foreign countries. Thank you for patient hearing.
Thank you, Dr. Anasoya Roy, for your presentation, and thank you for taking us in the deeper knowledge towards the antimicrobial capacity and the active copper technology. So moving forward, we have the address by Dr. Ajay Kumar, Chemical Department, Sharda University. Over to you, sir.
Express my gratitude to PhD Chambers for giving me this opportunity, for giving me this award. Because may I speak for,
Yes, please. Please.
so that I think that I am audible to all of you? Yeah. Right? And because we are in lunch time,
Thank you so much, Dr. Arish Sharma, for a wonderful presentation. And there is a lot of stuff that all the students and the people who are present today can take back from. So before I call my colleague, Mr. Arun Gupta, to felicitate our guest for the day, I would give my special thanks to all our sponsors, starting with the associate partner Imagine Fibers. I'm requested to kindly just settle down for a minute, please. Academics partner IIT Delhi, knowledge partner Fiber to Fashion, and media partner Textile Value Chain. So I would request my colleague Mr. Arun Gupta to kindly come on the dais and felicitate Professor B.S. Butala, Department of Textile and Fibers Engineering, IIT Delhi, please. A big round of applause, please. Moving further, we have Mr. Uma Shankar Sinha Mahapatra, Managing Director, Pulkra Chemicals India Private Limited. Up next, we have Mr. Shishir Tyagi, Deputy Director, Wool Research Association, COE Sportech. Next, we have Mr. Yeti Gupta, CEO, Fabiosis Innovations Private Limited. Next, we have Dr. Anasuya Roy, Founder, NanoSafe Solutions Private Limited. And last, the cherry on the cake, Dr. Ajay Kumar, Chemical Department, Sharda University. A big round of applause and thank you for being such a lovely audience. We'll be proceeding for lunch, and before that, we request all our dignitaries to kindly stand for a good photograph, please. Thank you, and we can proceed for lunch. Thank you so much.